Now let's solve exercise 1.3. Write the following in decimal form and say what kind of decimal expansion each has. Let's say first 36 word. So what will be the decimal form of 36 by 100? So let's divide 36 by digit 100. 0, 1, 600 is a 300. यहाँ पे रिमाइंडर क्या होगा 60 0 100 6 600. What is the remainder? 0. So 36 by 100 will become 0.36. So here we can see that it is terminating. So we can say it has the terminating decimal extension. So let's solve the second. 1 by 11. तो हम इसको डेसिमल फॉर्म में कन्वर्ट करेंगे पहले. So what will do? So let's divide the 1 by 11. So 0 point again 0. 11 number 99. So remainder is 1, right? 0, 0. Again 11 number 99. Again remember 0, 0 and 11 number 99. It will become 1. Hence the remainder will repeat as 1 and it will be like 0.09, 09, 09 and so on. We can write it as 0 point a block of 2 digits, that is 09. So we can say it is the decimal expansion of 1 by 11 is non-terminating and recurring. Because 09 digit is repeating, so we can say non-terminating and recurring decimal expansion. Next one is 4. So next one we can convert it into, it will become like uh, uh, 8 for the 32 and 33 by 8. So now let's see. So let's divide 33 by 8. Where 8 for the 32. Remainder is 1. 8 1 year. Remainder is 2. 8 2 is 16. Remainder is 4. 8 5 is 40. Remainder is 0. So here it is again terminating. So here what we get is, we get it is 4.125. So after 3 digit 3 division, we get the remainder as 0. So we can say its decimal expansion is terminating decimal expansion. So next is 3 by 13. So let's say let's divide 3 with 13. So we will get 13 to the 26. 13 3 the 39. 13 7 the 91. Remember is 9. 6 13 6 the 78. Remember is 12. 13 9 the 117 and remainder is 3. It will again start repeat when the remainder comes 3. Right? So let's say let's check. So 13 to the 26. 1.4. So it will start to repeat, right? So see here two starts to repeat. So we can say, so here if we write 3 by 13, so we will get 3 by 13 is equal to the 0.230769 block of these 6 digits. So we can say it is, it's terminating. No, it will never terminate. So it is non-terminating, and it is repeating. Yes, it is repeating. So non-terminating recurring decimal expansion. Let's check about 2 by 11. So let's divide 2 by 11 again. Point 11 1 11 9 11 is 2 2 11 1 11. The remainder are like 2. So again, it has started to 11 is 15. So and so on. So we can say 2 by 11 is equal to the 0.1818 and so on. So equivalent to 0.1 block of 1. Right? So we can say again it is terminating. No, it will never terminate. So the decimal expansion of 2 by 11 is non-terminating recurring decimal expansion. Right? So next one is 329 by 400. So let's divide 329 by 400. Let's divide 329 0. We will put a decimal. So 4 8 3200. Where the remainder are 90. We will extend the 0. So 400 2 800. Remainder are 100. Understand 0. So 400 5 sorry 400 2 800. So the remainder are 200. So again extend 10. So 400 5 2000. So here the remainder is 0. So again it is terminated. So we can say the decimal expansion of 338, we will get 8.0.8225, right? So we can say it has a terminating decimal expansion. Terminating decimal expansion. So next one, you know that 1 by 7 is equal to the 0.122857. So can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7 are without actually doing the long division? If so, how? Yes, we can do. Let's see how we can do. See, so we know that we can write 1 by 7 as 0.142857, right? And it is a repeating block of this. So we can say this is a 1 by 7 is a non-terminating repeating decimal expansion, right? So we can here say so we can write 2 by 7 as 2 times of 1 by 7. If we multiply by 2 into 0.142857, if we multiply, then we will get the value of this like 0.2857. Similarly, we will get 3 by 7 as 3 times of 1 by 7. So we get we will get the values like 0.428571 and it will repeat. So we are putting a block. So similarly, 4y7 will be like 4 into 1y7 equal to the 0.57142. 5 by 7, 5 by 7 we will get like 5 into 1 by 7 and that will be equal to the 0.714285. So similarly 6 by 7 will become 0.8571.2. Here we can say we can get the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 without actually doing the long division. Right? So here, next one is express the following in the form P by Q, where P and Q are integers and Q is not equal to the 0. Yes. So let's take first problem. So let's say X is equal to the 0.6. So we can write it as 0.66666. Right. So here's the equation number one. See, since single digit is repeating, since single digit is repeating, so we will multiply 10 on both sides of equation 1, right? So on multiplying the 10 on both sides of equation, we will get 10 times of x is equal to the 10 times of 0.66666, so on. We will get 10 times of x is equal to the 6.66666. So this is the equation number 2. If we subtract the equation number 2 from equation number 1, or we will subtract equation number 1 from equation number 2. So we will get subtracting equation number 1 from equation number 2, we get, so 10x minus x is equal to the 6.66666 minus of 0.66666. Correct? So we will get 9x is equal to the 6. X equal to the 6y9. We can also simplify it, so it will become 3 to the 6, 3 to the 9. So x equal to the 2 by 3. So this will be the, so this is the rational form of 0.6666. So next one is 0.47, right? So we consider it as, so next one is 0.47777. So let's consider it as x is equal to the 0.47, or we can also write it as 0.47777 and so on. So let's consider equation number 1. So since again the single digit is repeating, so we will multiply by 10 on both sides of equation. So on multiplying by 10 on both sides, we get 10 times of x equal to the 4.77777. So this is the equation number 2. So let's subtract equation number 1 from equation number 2. what we will get? We can write it as like 10x equal to the 4.7777 so on, and x equal to the 0.7 0.0777. So if we subtract it, so it will become like 9x, and 9x equal to the, it will become 4.3, right? So here we can say x equal to the 4.319, or we can also write it as x equal to the 4319. So here let's solve the next problem, that is the x is equal to the 0.001001 and so on. So this is the equation number 1. Here we can say since 3 digits are repeating, so we will multiply by, since 3 digits are repeating, so 1000. After multiplying on both sides, we will get 1000 of x is equal to the 1.001001 and so on. So this is the equation number 2. So again, subtracting equation number 1 from equation number 2. So we get, and x equal to the 0.001001 and so on. After multiplying, after subtracting, we will get 999 times of x is equal to the 1, where x equal to the 1 divided by 999. So this is the fractional form of this 0.001. Well, so let's move to the next problem. Express 0.9999 in the form of PYQ. Are you surprised by your answer? With your teacher and classmates discuss why the answer makes sense. Okay, let's solve the first part of the question. First, so हम convert करते हैं इसको in form of PYQ. So again, similar. Let's x equal to the 0.9999 and so on. So we can say it is equivalent to the 0.9 since digit 9 is repeating. Right? Right? So this is the equation number. So since single digit is repeating, so we will multiply 10 on both sides of equation. So let's multiply 10 on both sides of equation number 1. So here we will get 10 times of x equal to the 9.999 and so on. So this is the equation number 2. So subtract equation number 1 from equation number 2. We will subtract equation number 2, equation number 1 from equation number 2. So we will get like 10 times of x equals to the 9.9999. Equation number 1 is x equal to the 0.9999. So let's subtract this equation. So we will get 9x equals to the 9.0. Here x is equal to the 9.019. So we can say 9 1 ja 1, 9 1 ja 9. So we can say x is equal to the 1. So how is it possible? Right? So we are getting x equal to the 1 or 1 by 1. So are you surprised by your answer? Yes, at a glance, we are surprised by the answer. But see, but when we observe the 0.999 that goes on forever. So there is not, if we see these things on the number line, so we will say like let's say this is number 9 and this is this is zero point 0.9 and this is 1.0. If we take this 0.99999 forever, so we will say like there will be no gap between these two, the 0.9999 and 1.2. So that's why these two values are equal and it makes sense. So let's move to the next question. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Okay, so let's get the decimal expansion of 1 by 17 and we will see कि इसमें कितने digits जो है repeating block में होंगे. So 1 by 17, so हम 17 को 1 से divide करते हैं, सॉरी 1 को 17 से divide करते हैं. So what we will get? So 0, we will put the decimal, we will expand it. So again 0, we will expand it. So 17 5s are 85. What will be the remainder? Remainder will be 50. So we will expand 0. So 17 8s are 136. So we will repeat the process till we will repeat the remainder will repeat, right? So 17 8s are 136. So the remainder is 10, 4, 14. So again 140. So again 17 8s are 136. So here the remainder is 4. It will become 17 2s are 34. So remainder is 6. So 17 3s are 51. So remainder is 9. So 17 5s are, we will get like 85. So remainder is 5. So 17 2s are 34. The remainder is 6. 16. Remainder is 16. So 17 9 ja 153. So here again remainder will be the 7. So 17 4 ja 68. So the remainder will be 2. Here again further we will continue. So the remainder is 2. So here it becomes 20. Right. So 17 1 ja 70. Here is 3. So again 17 1 ja 70. So remainder is 30. So it becomes 130. So 17 7 ja 119. So the remainder is 11. So 76 ja 102. So remainder is 8. So 17 4 ja 68. And the remainder is 12. So 17 7 ja 119. So remainder is 1. So again 0. So 0 and this becomes 100. So it had started to repeat because we have got the remainder as 1. So again we will say 17 5 ja 85 and it will repeat the process. And it will repeat the process. So we can say 1 by 17, we will get the decimal expansion of 1 by 17 as, so 1 by 17 will equals to the 0.8823529411764705 and so on. So we can say 05 is repeating, so it will become like 0.88235294117647. So this is the repeating block. So how many digits are there in repeating block? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So we can say maximum number of digits कितने होंगे 16 16 so after 16 times of division the remainder will start repeating, right? So this is the answer. So let's move to the next question. Look at several examples of rational numbers in the form p by q, where q is not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representation expansion. So can you guess what property q must satisfy? Okay, so let's see. It is saying look at several examples. Okay, so let's see 1 by 2. So we have to look at the decimal expansion. Which decimal expansion? Terminating decimal expansion. Okay. So let's say 1 by 2. Its terminating, its decimal expansion will be 0.5. Definitely it is terminating. Let's say 1 by 4. So its decimal expansion will be 0.25. It is again terminating. 1 by 8. So it will be like 0.125. So again it is terminating. 1 by 5. So zero point 0.2 again it is terminating 1 by 25, so 0.04, so again it is terminating, so 1 by 10 again it is terminating, so 1 by 50, let's say 1 by 50, it will be 0.02, so again it is terminating. So these are the, so we can also take so many examples whose decimal expansions are terminating. So it is saying like, can you guess what property q must satisfy? So here we can see the q value of q is like 2, 4, 8, 5, 25, 10, 50, and so on. So here see, we can see when the value of q are like these, so its decimal expansion will always be the terminating. So we can say when the decimal when the q is in the form of 2 in the power of 2, 5, or both. Here we can see this is 2, this is the power of 2, 2 to the power 2, 2 to the power 3, this is the power of 5, this is again, and this is the multiplication of both 2 into 5, so this is again 2 into 5 into 5, so and so on. So we can say when the q is the power of 2, 5, or both, then its decimal expansion will always be the terminating, right? So all right. So next is, let's move to the next question. So write three numbers whose decimal expansions are non-terminating, non-recurring. So हमें कोई से ऐसे तीन नंबर्स लिखने हैं जिनके डेसिमल एक्सपेंशंस नॉन टर्मिनेटिंग हो, नॉन रिकरिंग हो. What does it means? Non terminating, non recurring. It means the number should be irrational. So हमने पीछे पढ़ा कि जब डेसिमल एक्सपेंशन नॉन टर्मिनेटिंग और नॉन रिकरिंग होता है तो वो किसका होता है? वो इरेशनल अपरिमेय संख्याओं का डेसिमल एक्सपेंशन इस तरह से होता है. तो वी कैन कंसीडर एनी काइंड ऑफ नंबर, लेट्स से, सो इट द नंबर विल बी लाइक थ्री नंबर्स लिखने हैं हमें. तो 0.02, 0002, 002, 00002, 0000019, and so on. So similarly, we can also write like 0.01, 0011, 00011, 0000011, 0000011, and so on. Next, we can also write like 0.13, 013, 0013, 00013, 0000013, and so on. So in this way, we can write the infinite numbers whose decimal expansions are non-terminating and non-recurring. Alright, so let's move to the next problem. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay, so let's find the decimal expansion of 5 by 7 and 9 by 11. So, let's write the 5 by 7. Alright, so let's divide 5 by 7. So we will get its decimal expansion. So let's say 0, we will put decimal and extend it. So 7 7 49. So remainder is the 1. 7 1 ja 7. So we will get remainder as 3. Right. So 4. So we will get like 7 5 ja 35. So we will get 5. So 7 7 ja. So I see we have got this 5. So again the remainder starts to repeating from this stage. So again 1 0 to 7 1 ja 7 and so on. So we can say 5 by 7 is 0.7142857142 so on. So we can write 5 by 7 as 0.714285. So we can say this is the repeating block, right? So similarly, we can write the decimal expansion of this 9 by 11. So let's divide 9 by 11. So we will write 0. So decimal, let's expand. So 11 8 are 88. The remainder is 2. 11 1 are 11. So decimal, so remainder is 9. So again, it has started to repeat. So again, it will repeat. So like put the decimal. So 11 8 are 88. Remainder is 2, and so on. So we can write as 9 by 11. The decimal expansion form of 9 by 11 is 0.818181 and so on. So we can write it like 0.81. So this is the repeating block. So two digits are in the repeating block. So we have to write the three different irrational numbers. So irrational numbers are always non-terminating and non-recurring, right? So we can say the three different irrational numbers between two rational numbers 5 by 7 and 9 by 11 are. So we can say this is 0.71. So like we can say like 0.8, 0.8, 0.08, 0.008, 0.0008 and so on. This is how, so we हमें तीन डिफरेंट संख्याएं लिखनी है, रेशनल अपर में संख्या लिखनी है. एक तो ये हो गई. अगेन लिख सकते हैं हम 0.72, 0.72, 0.072, 0.00072, 0.0000072 and so on. Similarly, we can write it like 0.78, 0.78, 0.0078, 0.078, and 0.00078 and so on. So these are the three different irrational numbers between two rational numbers 5 by 7 and 9 by 11. So let's move to the next question, that is classify the following numbers as a rational or irrational. Now we need to classify all these digits. So all right, so let's take the first problem at square root of 23. So as we will take the square root of 23, so we will not get as the integer, or we cannot write it in the form of p by q. So we will conclude that this is an irrational number. Let's take the second. So if we take the second number, that is the square root of 25, square root of 2225 will give us the 15 value. So this is a integer, right? Or we can write it in the form of 15 by 5. So we can say this is a rational number. Let's take problem number third. It is 3796 0.3796. So let's try to convert it in the form of p by q. So we can write it as 0.3796y1. If we cancel out the decimal, so there are 4 places after decimal. So we will put 4 digits. 4 शून्य हम रखेंगे एक के बाद. So we can also simplify it. So after simplification, we will get it as like 949 divided by 2525. So yes, 0.3796 को हम पी वाई क्यू के फॉर्म में लिख सकते हैं एंड इट्स पी वाई क्यू फॉर्म इज द 949 बाई 2500. सो वी कैन से हम कह सकते हैं कि यस दिस इज एन रैशनल नंबर. So let's take the another problem, that is 7.478478. So see, let's see this problem. So here we can say which digits are repeating. The repeating digits are 478, 478. So we can say this digit, these 3 digits are repeating, right? So we can say this is equivalent to 7.478, right? And for because this is making a repeating block. So let's consider it as x. So x equal to the 7.4784 and 8. So this is the equation number 1. Since 3 digits are repeating, so repeating block में how many कितने digits हैं? 3 digit हैं repeating block में. तो इसलिए हम कितने का मल्टीप्लाई करेंगे? हम 1000 का मल्टीप्लाई करेंगे. इसलिए हम 1000 का मल्टीप्लाई करेंगे on both sides of equation number 1. So we will get 1000 times of x equal to the 7478.478. तो ये बन जाएगी आपकी इक्वेशन नंबर 2. अब हम इक्वेशन नंबर 2 को सब्ट्रैक्ट इक्वेशन नंबर 1 को सब्ट्रैक्ट करेंगे इक्वेशन नंबर 2 से. सो वी विल राइट दैट इक्वेशन नंबर 2 माइनस इक्वेशन नंबर 1. सो वी विल गेट 1000 times of x equal to the 7478.478 and so on, and x is equal to the 7.478478. So after subtracting, we will get 1000 minus 1 is 999 times of x is equal to the 7471. Right? So in this way, we will get like x. This implies that x is equal to the 7471 divided by 999. So this is the fractional form of x, or we can say we can write x given number 7.478478 in form of p by q. So in this way, we will say this is again a rational number. So now if we look, let's take another example, that is 1.101.001 triple 001 10001 and so on. So yeah, see, so none of the digits is repeating. It's not definitely it's non-terminating, but any digit is repeating. There is any pattern? No, there is not any pattern, or and there is not any digit. Uh, 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 any digit is not repeating, right? So we can say none of the digit is repeating. So we can say it is an irrational number because it is non-terminating, non-recurring. We will say it is an irrational number। आई होप आप सबको ये समझ आ रहा होगा।